السلام عليكم ورحمة الله وبركاته. حبايبنا طلبة الصف الأول الثانوي، أهلا بكم ودروس مادة الفيزيكس. معاكم مستر محمود حافظ سينيور فيزيكس تيتشر في مدرسة حسن أبو بكر التجريبية الرسمية لغات. هنبدأ دلوقتي مع الدرس الأولاني في lesson 1 اللي هو measurement. في measurement, what we mean by measurement, it is a comparison between two physical quantities. The two physical quantities, one is known, which is called the tools, and the other is unknown, which is called the physical quantity. So we have this is called physical quantity, which is unknown. Number two, tools, which is known because it has units. So we have three keys of measurements. Number one, physical quantity. Number two, tools. Number three, units. We will discuss what we mean by each of one. Number one, physical quantity. We have two types of physical quantities. Number one, fundamental. Number two, derived. Okay, fundamental, it is a physical quantity which cannot be derived from other physical quantities, such as mass. Number two, length. Number three, time. But in the derived physical quantities is a physical quantity which can be derived from other physical quantities as velocity, which equals displacement divided time. So if you wanted to calculate the velocity, we need to calculate the time at first, number two, the distance, and we make a division, distance over time, to calculate the velocity. Here we have acceleration, delta v over delta t. So if you wanted to calculate the acceleration, you need to know the velocity, the change in the velocity, and change in the time. Okay, so it is a derived and fundamental physical quantities. Here we have in the fundamental electric current intensity, which is measured in ampere. Number two, here we have the quantity of a charge, in the derived physical quantities. Number two, we will discuss the tools. We have tools for mass, length, and time. Firstly, in the mass, the tools of mass begins from Roman scales, and till now we have the digital balance. Number two, in the length, from the arm as the tools to measure the length. Till now we have a vernier caliper and micrometer. Vernier caliper to measure the very small length. Number three is the time. We begin with different tools until we have the digital watch and electronic watch or cesium clock. So we have different tools for mass, length, and time. What about the units? The units here, we have three systems for units. Number one, French. Number two, British. Number three, metric. Okay, French system, we have centimeter for length, we have gram for mass, and second for the time. Number two, in the British, we have foot and about the mass, we have pound, which is called IP. Number two, foot, FT. Number three, second. Second is a common units in British and French system. British system is French system is called the Gaussian system. Number 3, metric system. Metric system, here kilogram, meter, and second. So the common between the three systems, second, centimeter, gram, second. So it's called CGS. Number 2, FPS. Number 3, metric system, KMS. Okay. Here we have the French system. We can summarize it as the following: CGS, which is called the Gaussian system, the British system, FPS, the metric system, KMS. We will find the relation between these units. Here, 1 meter equals 3.28 foot. Okay. Number 2, pound, 1 kilogram equals 0.45 for the pound. Okay, IP. This is the relation between distance and in different systems, and also the mass in different systems. Now in 1960 we added, in a conference we added 4 extra units. Here we have electric current intensity in ampere, luminous intensity in candela, the amount of material in mole, and electric temperature in Kelvin degree. So we have 4 extra units added to the metric system, which becomes a building unit of international system, which is called SI. So SI is the international system, begins in 1960. We added 4 extra units to the main basic units: kilogram, meter, second. We have electric current intensity in ampere, luminous intensity in candela, amount of material, mole, and temperature in Kelvin. And we added extra 2 units for the angles. Number 1, radian. Number 2, steradian. Radian for the angle, plane angle, steradian for the solid angle. Okay. Now we will discuss the tools, units, and different units on different system. Okay. Now we'll discuss how we can use the vernier caliper. It's one of the tools which can use very small lens. Here, vernier caliper consists of, it is a fixed scale which we called as X. Number 2, we have another scale which is called the vernier scale. We called it X small. So we have X capital and X small. The total reading of vernier caliper can be expressed in the following: X capital plus X small. Here begins with 0, 1 centimeter, which equals 10 millimeter, 2 centimeters, 3 centimeters, 4 centimeters. This is the fixed scale. Here we have 2 jaws, and we will put the object which we want to measure its length or its diameter between the 2 jaws. Okay, so we have another scale. The other scale begins in 0, 1, 2, 3. So we have very small difference between 1 centimeter in the vernier scale and 1 centimeter in the fixed scale. The difference here, which equals 0.1 millimeter. This is the difference between the two reading in the fixed scale and the vernier scale. Suppose we have 0 becomes between 19 millimeter and 18 millimeter. So the fixed scale x capital, which will be equals 18 millimeter, which equals 1.8 centimeter. Here x small will be equals, we'll search for the number which lined up from the Vernier scale lined up with the fixed scale. Here we have 3 lined up with 4. 3 lined up with 4. Okay, so we will take 3 multiply 0.1, so it's equal 0.3 millimeter. So the total reading of Vernier caliper will be equals x capital plus x small equals 18 millimeter plus 0.3 millimeter, so equals 18.3 millimeter. Okay, this is a Vernier caliper and how we can use it. The difference here, we will search for the number which lined up with another scale on the fixed scale. Okay, so another example. Here we have a Vernier caliper. We will put the object between the two jaws of Vernier caliper and 0, 1, 2, 3, 4. Suppose a 0 here from x small becomes lined up with 2. Lined up with 2. So the reading becomes x capital equals 20 millimeter, x small equals 0, so the summation will be equals x capital plus x small equals 20 plus 0 equals 20 millimeter. So we don't have to search for the number on the Vernier scale which lined up with another number on the fixed scale. Okay, number 3. Now we will discuss the number which is called the standard value or standard formula. Here 10 equals 10 power 1, 10 power 2 equals 100, 10 power 3 equals 1000. This 10 power a certain number is called the standard formula. So if I wanted to express 1000, I can be written as the following: 10 power 3, 110 power 2. What about another one? Here 1 over 10 power 3, which equals 10 power negative 3. 1 over 10 power 2 will be equals 10 power negative 2. So this is called a standard formula. If you want to write it 0.01, here 0.001. So 0.001 can be written as 10 power negative 3, 0.01 can be written as 10 power negative 2. Here 1 over 10 equals 1, 10 power negative 1, which can be written as the following: 0.1. This is called the standard formula of this number. Now we will discuss how we can change or convert from unit to a certain unit. Here here we have meter, another unit called centimeter, millimeter, micrometer, nanometer, angstrom. Here we have kilometer, megameter or gigameter. Okay, here we have 1 meter, which equals 10 power 2 centimeter. 1 meter equals 10 power 3 millimeter. 1 meter equals 10 power 6 megameter equals 10 power 9, 10 power 10 from the angstrom. Here 1 meter will be equals 10 power negative 3 from kilometers. Here 10 power negative 6 and here 10 power negative 9. So if you wanted to change from centimeter, suppose we have 3 centimeter. How many how many, the value of 3 centimeter, how many in kilometer. So we will make cross multiplication. Here 3 multiply 10 power negative 2 divided 10 power 2. Here, which equals 3 multiply 10 power negative 3 multiply 10 power negative 2, which will be equals 3 multiply 10 power negative 5. Here in kilometer. Okay, another one. Suppose we have 7 millimeter and micrometer. 7 millimeter, how many equals in micrometer? So we'll make a cross multiplication. 7 multiply 10 power negative 6 divided 10 power 3. So 7 multiply 10 power negative 6 divided 10 power 3, which will be equals 7 multiply 10 power negative 6 multiply 10 power 3 negative 3. So 7 multiply 10 power negative 9. Here in megameter. Okay, now we will discuss the standard units. Here we have standard units for mass, standard units for length, standard units for time. For mass, the standard unit is a standard kilogram, which will be equals to a cylinder of platinum and iridium. This cylinder has a certain dimension, 39, the diameter 39 millimeter and its height 39 millimeter. This cylinder made of platinum and iridium alloy, especially platinum and iridium alloy, because platinum and iridium alloy rigid and slightly affected by the weather conditions, or you can say it that it's doesn't affected by weather condition, doesn't affected by increasing in temperature or decreasing in temperature, and especially it is rigid. Here the platinum and iridium alloy makes a cylinder, this cylinder with a certain dimension, which is called 1 kilogram or standard kilogram. Okay. Number 2, the length. The same alloy, platinum and iridium, used to make a rod. This rod has 2 engraved marks at its ends. The distance between 2 engraved marks divided into 100 centimeter. This distance is called standard meter. Okay. Number 3, the time. We have one day, which equals 24 hours. Multiply 60 in minutes, multiply 60 in seconds, so it will be equals 86400 seconds. So 1 day equals, the average day equals 86400 seconds. So 1 seconds will be equals 1 over 86400 from the average day. So the seconds is the period of time which equals 1 over 86400 from the average day. By the time we have atomic standard meter and atomic seconds. Atomic standard meter by using atom krypton 86, it will produce a certain number of wavelengths, and we have here a detector to calculate the number of wavelengths. This wavelengths, these waves produced inside a tube. This tube vacuumed from the air. So we can call meter or atomic standard meter as a distance which equals a certain number of wavelengths or waves produced from krypton atom in a tube. The tube vacuumed from air. And also the same, here we have an atom of cesium used to produce a certain waves as it works for 1 second. So 1 second equals a certain number of wavelengths, which equals 919.637.1700 from the waves. So we don't need to save the number, but here you need to define the atomic cesium atom or atomic cesium clock. Okay, this atomic cesium clock is very accurate. It can be used to determine the time of Earth's spin, number 1. Number 2 used to determine the time of spacecraft or space shuttles, the journey of the spacecraft. Number 3 used to determine the time of navigation and deviation. Okay, this is the atomic cesium clock. Here we have the standard units. Now we'll discuss a new point which is called dimensional formula. What we mean by dimensional formula? Dimensional formula, it is the basic component of any derived physical quantities. So, by using dimension formula, we can express any derived physical quantities in the terms of fundamental physical quantities. We have mass. We can summarize this as m. We have length. We can summarize this as L. We have time. We can summarize it as T. Suppose we have velocity, which is equal to the change in the distance over change in the time. Here we have a distance or length, we can substitute it with L, and the T, time, we can substitute it with capital T. So it will be equals to LT power negative 1. The unit will be equals meter second power negative 1. We can write it as the following: meter per second. So this form is called dimension formula, which expresses the main component of the velocity. Number 2, acceleration. Here, change in the velocity, change in the time. Change in the velocity, we have the dimension formula LT power negative 1. Change in the time, T. So LT power negative 1, T power negative 1, which will be equals LT power negative 2. We can use the dimension formula to verify its unit. So its unit equal meter per second square. Number 3, the force. The force equals mass times acceleration. So mass can be written or summarized as m. Acceleration LT power negative 2. So finally we have mLT power negative 2, which is called Newton. Can be written as kilogram meter second power negative 2, which is equal to Newton. We have extra examples as the pressure. The pressure equals force divided area. So we have the force. The force is the backbone of any dimensional formula in physical laws. Here force equals mLT power negative 2. Area will be equals L times L, length by length. So we can summarize it as the following: m L power negative 1, T power negative 2. So this is called Pascal. Kilogram meter negative 1 second power negative 2. We have another one, work, which equals force multiplied displacement. So the force m L T power negative 2, and displacement is L. So m L power 2 T power negative 2. This is called kilogram meter power 2 second power negative 2, which is equal to joule. Okay, we have extra example. The volume equals length by width by height. So we can summarize that L times L times L will be equals L power 2 power 3. The unit will be equals meter cube. Another one, area, length by width. So L times L will be equals L power 2. What is the importance of dimensional formula? Dimension formula expresses the units, expresses the main components of any physical quantities, derived physical quantities, and we can express any derived physical quantities in the terms of fundamental physical quantities. So finally we have to use the dimension formula to verify the laws. First, we will discuss number one. If you have 5 kilograms, you can add 5 kilograms to 3 meters to find the result. We can add different units to each other. Number one. Number two, we have 1 meter can add to 20 centimeter. They have different units, but we can add them after converting one of them to each other. Here we have 100 centimeter can be added to 20 centimeter. It will produce 120 centimeter. Okay. Number two, the function of dimension formula is to verify the physical laws. Suppose we have kinetic energy equals half mass velocity square. By using dimension formula, verify the following law. Here we'll divide our page into two sides, left hand and right hand. Kinetic energy is force multiplied displacement. Force mLt power negative 2 and the displacement L. So finally mLt TL negative 2. On the other side, any value 1, 2, 3, half, by, this is value without units, so it doesn't have dimension formula. We can neglect them. Mass m and the velocity lt power negative 1 all power 2. Here m, we will distribute the power l power 2 t power negative 2. So finally the mass similar to the mass on the two sides, L power 2, L power 2 and T power negative 2, T power negative 2. So by using dimension formula, the law is correct dimensionally. Here we have factor. The dimension formula doesn't treat the factor, so it may be right by a percent, 99% as an example, but not 100%. The rule is correct because the dimension formula doesn't deal with the factors half. Another example to verify the law. Here we have V final equals V initial plus 18. This is a physical law. We wanted to use the dimension formula to verify it. Here velocity Lt power negative 1. Here velocity Lt power negative 1 plus acceleration Lt power negative 2 times t. Lt power negative 1 is constant. Here Lt power negative 1 plus L t power negative 2 times t power positive 1, so t power negative 1. We have t power negative 1 with t power negative 1, so they will be equals L t power negative 1, L t power negative 1. They are similar because we don't treat with the factor 2, so we can neglect it. The L similar to L, T negative 1, T negative 1, so dimensionally the rule is correct. Okay, and we will discuss extra solvent or extra examples in the next time. Wassalamu alaikum wa rahmatullahi wa barakatuh.